So now we're in MasterCAM. Yay. So you can directly open your Rhino file right from here. So go to Open, and choose your Rhino file. And voila. We're going.
Recording. Oh, okay. Yeah, so when you're in Rhino, you have whatever your geometry is that you're designing. Basically what we're going to do in here is actually simulate the bed itself. So it's a 5x10 bed, so we're just going to draw a rectangle. We're going to start at the corner of the origin here. So there's the actual bed of the thermoid itself.
Size?
The 5x10. And then we're going to offset 1.5 inches because that's what we did downstairs with that operation. So this is where we're going to actually put our stock. So if you have the bed 1.5 inches off on both sides, and that helps us align things perfectly. Can you stop it for a second?
And we're back.
Alright, so we've got the size of the table, the 1.5 inch offset. Then we're going to move the geometry over to the 0, 0, or the, oh my goodness. I'm not used to using the Mac at all. Alright, save it. Oh my god. Okay, so what we're looking at right now is the 10x5, and over here is the gantry with the spindle on it. So the tool holder bar is back here, and then the computer's over here. And what we have to do is move this geometry over here because when we're in MasterCAM, we've got to do this shift, which you'll see at the end of MasterCAM when we're writing the G code itself. And that just has to do with how things are oriented in MasterCAM. So this file, Andrew, did you set this up for surfacing or?
In Rhino?
Yeah, like is there I can't think of the word.
Okay.
So for this project, we're going to be doing surfacing. So actually so if this is our design, when you do surfacing, you need to contain it. So that's a MasterCAM term. When you're in MasterCAM creating your tool paths, basically the containment's telling it where the restraints are, or the constraints of where the tool should travel. So in Rhino, you need to, this mouse is terrible, is duplicate borders. So we're going to have to bring in curves in addition to the actual surface that we're milling. So I'll set that up and then we'll save it and head over to MasterCAM. Hold on. Because this is the flip, so we're just setting up the one side right now.
Yeah, so okay, so we're going to put a containment around the outside. We're going to duplicate the edges here, and then I'm going to join them. And then for the heck of it, I will duplicate this as well. Then I will contain that, just so we have them. And then here, should it be like that?
Yeah, give yourself one there.
Okay. And so this is a double-sided mill. We're just going to work with the top side for the moment. Okay. So we're back in MasterCAM now. Let's open up our file. Where is it? Nobody knows. So it's a Rhino file. Go into Rhino, 3DM. Oh, that's nasty. Okay. And it's missing everything.
Zoom.
Oh, there's something else hidden there.
Yeah.
That's clean geometry.
Over here, there's a little cross with arrows, and that's your zoom extents. And middle mouse button to orbit, and then Alt middle mouse to pan around. And then over here, you have your different views. So when you create toolpaths, you should always be in the top view. One of the common problems that you run into is sometimes you won't actually be in top view and you'll have done everything perfect and you're just like struggling to figure out why. And if you look down here or in the toolpath we set up itself, this should be in top view. And then another thing to always make sure is over here your machine group is for a thermwood, because that's what we have downstairs. So if that isn't that, then you'll have to go over here, mill, and pick thermwood from there. Okay, so over here, if you expand this, we can go to stock setup first, and what we're going to do is just simulate a piece of stock over here, so when we do our previews, we can see if it's milling correctly and how we want it. So we want to display it. Over here, we don't want to place the stock in the middle, so just click over here in the corner and we'll set that by hitting the arrow. So stock origin, the coordinates, that's what we need to pick. So do that. Come over here, click there. So this is the position it's in now, and then we need to put in the dimensions. So do you know what those are, Andrew? If you don't, we can just, if you don't know the exact dimensions for the purpose of the simulation, you can just make up something. So, for example, I'll just do 30 by 30, but you do want to know the Z height. So was that 2 inches or?
1/11/16.
All right, what is that in decimal? So 1/11/16 is 1.6875. Hit OK. And then this dashed box is just a simulation of your material. It has nothing to do with reality in terms of what MasterCAM or the code thinks is your actual stock size. It's just for the preview. Okay. So we have that done, then just click your mouse over on that red arrow, and so now we're sort of positioned there because the toolpaths are going to populate over here. So toolpaths, we are doing surfacing, so surface high speed. Check off yes. It wants a name, so you can just kind of go with the default. Now it says select drive surfaces. So your drive surfaces are the surfaces you created in Rhino. So we are going to start at the top. So we want these 4 surfaces, and I'm not sure if it's visible completely, but they will change color. So I think when we do this, you have to sort of strategize some type of logical order as to how you want the machine to mill it, because each step, so what we just did right now, if we hit enter and create the toolpath, the mill is going to look over here and it's going to go in order, so it would be like 1, 2, 3. So right now this would be toolpath 1, so that's the first thing it's going to do. So you have to, like I said, plan out how you want to mill this. So for example, if we were just milling this much and this was our whole stock, we wouldn't want to just cut out the part we wanted first and then do all the surfacing, because you'd want to be able to use all of this area to help hold down the part that you're actually milling. So that's why I'm saying strategize right here. So we picked our drive surfaces and hit enter, and then it's going to pull up this window over here. So this allows us to add or remove drive surfaces. And then containment, that's back where we had those curves that we created in Rhino. So let's select our containment. And the way this works is there's chaining. So right now, the way this is selected, it's a chain, so you'd be clicking on like 1 curve, 2 curves, 3 curves, and it's just gonna follow them in order. You can also, depending on what you're working with, you can just window all of them. But when you start to do surfaces like this, usually you have to do them as a chain. And the order in which you contain them doesn't really matter. So we'll start down here, and you can see it has a start and it's traveling around. Then we want to try containing out here, so right there it's only done 1 of those curves, so we have to go around and select each one, and you can see that actually with just 2 clicks it selected all 3 of those sides. So you press OK, and then it wants a start point, and this is where the spindle will actually come down and start doing work. So it can be, again, selecting up top there, press OK. So what we're going to do first, right, the way milling works is you'll do rough cuts, which you're just removing large portions of material, and then we'll do finish passes as another series of tool paths, and that's what's going to give you whatever your finished surface is that you want. Okay, so rough, we're going to just do area clearance. We're going to pick a tool. Often will give you some default, but it's usually not what you want. So you can go to the tool library over here, and then it's going to pull up a bunch of tools. We obviously don't have all of these, but we do have some. So like, for example, tool 235 that we use to fly cut, that's over here, and that's where you would select it. For roughing though, and this is where you have to think about what your material is. So we have a piece of hardwood we're going to mill, and we want to do our rough cut. So we're going to want something beefy to do that. So we'll go with like a 1/2 inch flat. We'll try that out. So press OK. Then over here, it's going to want information about what you want the spindle to do. So the feed rate, if you remember, that was the knob downstairs on the mill that we can control from 0 to actually 120%. So what we've always done, there's a maximum feed rate, which is 500 inches per minute, so we set that. Then the plunge rate is how quickly the spindle will move into the material. So it's kind of a good idea to let that be a lot slower than the feed rate, which is how quickly the spindle is going to be moving through your material when it's actually cutting. So I usually do a little less than half. and the spindle is always going to be clockwise. Now the spindle speed, there's actually a calculation we'll have to do, which is going to require the use of a chip load chart, and that's going to give us the spindle speed to use. In this, well, it'll give you a precise number. It's something you just have to tweak and experiment with based on, you know, how sharp your tool is, sort of what the actual material is that you're cutting. So it kind of gives you a close number to use, but not necessarily exact. Can you stop?
Here's the chip load chart. It can be found on the Vortex Tool website.
Yeah, actually I should mention that because
It's not Vortex Tool
are we
chip load. Yeah.
Okay. So yeah, like Andrew's saying, this is the Vortex Tool Company's chip load chart, and the reason why we chose that is because we're using Vortex tools, so these are kind of the values they've engineered based on their tools. So the way this works is we have a 1/2-inch diameter tool we're using, and it's hardwood, so they give you this range of values, and the calculation is over here. So the RPMs for our spindle is going to be feed rate divided by the number of flutes times the chip load. So we have a 1/2-inch tool downstairs with 3 flutes on it. So let's do 3 times, and the hardwood says we can try 0.019. So we're going to do the feed rate we set in MasterCAM, we did 500, so let's do 500 divided by 0.057. So that gives you a value of 87,771 RPMs. So this is where it's kind of giving you a rough value, and for the larger the diameter of the tool, the faster the spindles should be. So I would round this up to maybe 9,000 at least, but maybe you would want it to be a little faster even than that. And then the retract rate over here is how quickly the spindle is going to pull out of your material. So right now it gives you a default value of 6, which is fine because we're always going to check off rapid retract, and that's just to save us time when we're actually milling. Okay, so basically what you have to do is go through this list very carefully. The holder we don't do anything with. Now, cut parameters, this is pretty important. We're going to climb, we're going to do step down, so 0.05. That sounds pretty good. And when you're rough cutting, actually no, let's change this step over. So for a 1/2-inch tool, we could go as Vortex has told me we could go a 1/2 inch deep, but we're not going to do that. We'll go with, like, let's try a 1/4, for example. And then over here, so these things we have always left as the defaults. Same thing with the XY step over, and same with this. Over here though, the tip compensation we always leave at the actual tip, and then stock to leave on walls. When you're rough cutting, you can leave a small amount of material on, and all that really is doing is just speeding up the amount of, or reducing the amount of time that you're down there milling, because basically the finish passes will clean up this little bit of material. And again, like, this all kind of depends on, still may affect the finish a little bit, but also if we're doing the hardwood, I would set it to 0 because when we go in and do our finished passes, it's most likely going to be a smaller diameter tool, and because it's hardwood, we don't want that other tool to be doing a lot of extra work that it doesn't need to do. Okay, trochoidal motion, just leave that as it is. Transitions, same thing, we're going to do, so basically the spindle's going to come down like this to enter the material. Steep shallow, so we want to use Z depths. If we don't do this, the surfacing operation, it won't actually do a step down, it'll just plunge down all the way. So our maximum depth, what did we say, is 1.675? It should be 1 and 11/16 is going to be
6875.
6875. Okay. Linking parameters. This is another important one too. So retract clearance plane. That's how far. So if this, for example, was our material thickness, if it was 2 inches and this thing is defaulted to 2, it's only going to retract to the top of this, and that will most likely cause a problem. So I always like to set this pretty high, so even here, like I would do, say 4 inches, to make sure that you clear your material completely, and you don't want to ruin your piece by this thing retracting only like 1.5 inches and ruining whatever your piece is. And then over here, this is sort of an efficiency thing as well. Like it can do this retract just a certain distance away from the actual part, like you can see in the diagram. But again, just to make sure you don't ruin your piece, do a full vertical. Then these other parameters down here. Okay, so this one is important to planes. You want all your planes to be in the top view. So when we hit OK here and generate the tool path, if we didn't see these blue lines and these yellow verticals, and we did everything correct over here, one of the problems could be was that we generated the tool paths in a different view, so maybe a side view or something like that, and then you wouldn't actually see everything. So you want to go into your parameters, planes, and make sure all this stuff is set to top. So when we hit OK, actually, depending on the complexity of the geometry and what you've done, what you've set up for parameters in terms of the tool paths, like the amount of step overs, and if it's a rough or a finish, over here you're going to see a little spool, like a needle and thread kind of spool, and that means it's generating the tool paths. And that can, depending on what you're milling, can take a few minutes actually. It's not always just like a 3-second thing.
Did you show how to make sure you don't cut through the bed, the Z depth?
Yeah, we did Z depths.
Okay.
Yeah. Okay, so right now, it's generated a rough pass for this one surface right here, and exactly what it means by rough pass and what it's doing there. So what we do is to preview something, you can see the little folder over here has a little green check mark, so that means it's going to preview what's checked off over here. So you go to this little verify selected operations, little icon, looks like an extruded little piece of molding or something. So here's that simulated piece of stock, and what we're going to rough out is roughly right there. And they give you a few different options for how you verify what you're doing. So over here, this little tornado swirl is like turbo, so it'll do it in like 2 seconds. But then these other two give you a little more control over how quickly it generates the preview. And I like to choose this one over on the right because it shows the tool holder as well. So it just helps you understand even better what exactly you're doing, and if there were conflicts, you'll be able to visualize that better. And then also when you do this, it's recommended that you verify it using not doing turbo, because the quality of the display over here will be really compromised, and it won't give you an accurate representation of the finish you're getting. And it also, sometimes if there are conflicts like the tool holder crashing into your material, it won't show that as well. So I show the tool holder, and then you just hit the play button, and you can see this is what it's going to do right now if we went downstairs and milled it. So we have this. So this is what the roughing would do, where you see it just took out large pieces incrementally. And then when we come in with the finish, that's when we'll start to get our nice smooth surface. And another thing we also have to deal with is removing this big extruded circle. So we check that out, that's great, okay, and then we move on and generate our next tool path. Stop it.
Okay, to clear up the mass of stock we had left in the center of the mill, we basically removed the circular containment around the bottom, so we were left only with the square containment at the top. Sometimes when you run the simulation, you'll see that there's issues with material left over, and you may have to retweak your containment areas in order to clear that problem up.
Okay, so we have one of the rough passes set up. Now all we need to do is copy this and paste it below. You want to make sure that you've highlighted the red arrow when you paste it, because that helps you control the order, and you can toggle up and down if you need to insert tool paths in between existing ones. So when you copy it, open your parameters folder again, and this time, because you made the copy and we're setting up a new set of drive surfaces, you click on this, which eliminates the existing drive surfaces associated with this particular folder. So we want to do that. Same thing with the containment, and you can also do it with the start point. So our new drive surfaces are over here.
No, 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 left, left. It's just the ones at the corner. No, further, those.
Nope. Oh, let's stop. Let's stop filming.
So setting up our new containment.
So we'll see if that works.
And our new start point.
Now, all these should remain the same, but you should always, at the same time, just click through and quickly glance over and make sure that nothing has changed. And then over here, because we copied it, we have to manually regenerate the toolpath. So when you see this little X over here, you can just click on that, or up here there's these toggles too to regenerate the toolpaths. So when you do that, get this little error message, just click the green check mark, and again click off on the back plot, and you'll see that it generated the toolpaths. And if you noticed, when I selected the containment. I just used the curves at the top here, so that could cause a problem, but we'll just have to preview it and see what it did, because sometimes you, for example, you can be very economical with containment in that it doesn't necessarily have to follow the complex curvature of whatever your geometry is. Sometimes just a simple rectangle around it is enough. So containment's one of those things you always have to sort of experiment with. And we can preview just this part alone over here. Whatever's checked off is basically what's active. So let's just run a preview. Does that look like what you designed? Does it carve this out, or?
So what we saw was that we missed two surfaces in the drive selection, so it actually cut down to the bottom of the stock, so we need to reselect and make sure that we have 3 surfaces instead of 1.
So how we did that was we went to the parameters folder again, and you just click on drive, and then oh goodness.
There you go. There. Oh, wrong one.
That was it. So regenerate. Check off OK.
That looks about right.
So that looks, yeah, like we're getting that curvature. So this folder's checked off again. Let's preview it. Remember to do a slow preview for accuracy.
Perfect.
Okay, good.
Go.
So the next step is to do our finish toolpaths. So again, from the drop-down menu, toolpaths, we'll do another surface high speed. So this is going to pop up just telling you about some feature. Click OK, and then it's the same deal where we're selecting drive surfaces. I'm not a Mac user, so this is kind of crazy. So this time, we have 2 options from toolpath type. We're going to do a finish now, and you can see there's all these different options, so you can experiment with these, see what works best in terms of giving you the finish quality you want and the type of toolpath aesthetic if you want that to be part of it. For this, let's try a waterline. And so for a tool we use that 1/2 inch flat, but now we're going to do a finished tool path and would like it to be quite smooth. So let's try, for example, a 1/4 inch ball nose. I believe that's 252. Okay, so feed rate, start off at the maximum 500 and we'll do a plunge of 200. And then for our spindle speed, this is where we need that chip load chart again. And I guess one question maybe, why do we always use this feed rate of 500? And that's kind of a issue of how much time it's going to take us to mill this, so we always just max that out. And let's get the chip load chart open. And this is also a Vortex tool, so we'll use their published values again. Alright, so do you want to stop and we'll just do the calculation?
It's going.
Alright, so we calculated our chip load chart value and came up with the spindle speed of 28,000. So you can see there's a big difference. And also when you go through these parameters, so we've never changed the FPT number and we've never changed this SFM number either. It seems to be that MasterCAM is calculating some kind of value and it changes it based on these other parameter inputs that we use. So, and then this is always set to clockwise as well. So you shouldn't have to change that. Okay, and then our parameters. So our step down right now is less than a 32nd of an inch. So let's change that. Try an 1/8 of an inch. And your step down, like, you have to think about the diameter of your tool and what kind of material you're working with. So this is hardwood and we have a smaller diameter bit, so maybe prudent to go with a slightly smaller step down instead of, you know, a 1/4 inch or something more aggressive like that. And then we're doing a finished pass, so we don't want to leave any stock on the wall, so that's already defaulted to 0. Trim to stock, we don't do anything here. Same thing with transitions, we've always just left this default. And then steep shallow, it's already defaulted to that maximum depth, which was 1 and 13/16, I think it was. And then our linking parameters as well, the retract remained the same that we had established before, and same with the method of the retract. And all our planes are in top view, so should be good.
So after we finished our smooth pass for the large one, we're repeating the process over again, copying the toolpath file that we did below the previous one, and basically just repeating the process. And basically you will just continue this until you have gotten all of the paths complete. A quick note is, after we ran the first simulation, we realized that our step downs in the finish pass of an 1/8 of an inch were not enough, so we basically cleaned those up to 0.03 inches to get the required result, or desired result. Do it live.
Alright, so one way of being more accurate with our stock simulation is over here under the properties, go to stock setup, and what we did was, instead of these dimensions that we plugged in, you can do a bounding box. And what you do is pick that box that we had drawn in Rhino as our bounding box, press enter, leave these as they are, hit OK, and you go up to our preview, you can see that it made the stock exactly the shape of our material. You can run it. And you can see actually it's just doing the finish pass because that was the only thing that was checked off. So you can just click on each one individually, or you can click on the group itself, and you'll see when you do that that they're all selected. And you can turn toolpaths on and off individually. So if I click on this first folder, you'll see where it says toolpath, and it gives you the amount of data. Right now it's kind of grayed out. So you can go over here where these little wavy lines are, and that'll toggle toolpaths on and off. So you may want to do that because things can get kind of messy, so it's just a way of being neat and kind of organized with your work. And then also you can move things. Well, actually, first layers wise, down here where it says level, that pulls up your level manager, which is really your layers. So you can see, you click what's visible and what's not. And then the other thing that's kind of nice, if like you have a big piece of stock and you've got a bunch of parts laid out on it and you really just needed to move things a little bit, you can just select everything, go up to X form, translate, and it's going to pull up this box, and then it's going to be defaulted with this radio button that says copy. You want to check move and then put in your dimensions. So I'll just move it 5 inches, and what it'll do is it'll move all the tool paths with it, but you have to regenerate them first. Notice so it didn't take the stock with it, but this is a really nice feature because otherwise if you just move something, you'd have to go in and reselect all the drive surfaces and containment, yada yada, and that can be extremely time consuming to do. So those are some of the other more nitty-gritty kind of details about working in MasterCAM.
Quick note that I just thought of a while ago but didn't say it. Like one reason this is going so quickly is because we have very nice clean surfaces. If you work with meshes, you may have thousands of surfaces that you have to select in order to get your drive surfaces working. So keep your surfaces clean. Oh yeah.
Okay, so this part that we're milling is double-sided, and the easiest thing to do is a file merge / pattern, and when we do this, we can basically preserve all of our tool paths, or tooling parameters that we've set up, and we just delete this existing geometry and do a file merge. But first do the save as, and we'll just give this name bottom. So we did a save as, now we have our new file. Just gonna select all this stuff, delete it.
That delete might not work on the Mac button. You might have to go to like edit, delete.
Okay, yeah. So you want to delete all selected entities. now all that stuff is gone, and you'll see that over here there's no geometry for the tools. So here's where we do our file merge, and we want
that one, the bottom.
Oh, 3DM mill test May 2014 bottom. Bring that in, and all this stuff is kind of highlighted, just giving you some options when you brought it in. Just hit escape, and now over here you just have to go through the same process of selecting drive surfaces, containment, yada yada. But that's a real time saver. And did we do change recognition before?
No.
Like another thing is change recognitions as well. So in Rhino, say you made an edit, like you wanted to fill in this hole, for example, you can go over here and do change recognition. So we would select that Rhino file again. I'm just going to do it, and we'll delete it. But so then it pops this up, and geometry display, you want to show the incoming file, and it should remove kind of what's existing and give you your updated stuff. But there was actually no change recognition, so I just wanted to show that to people so they know that's there. So instead of deleting everything and having to set all that stuff up again, you can just do the change recognition if it's a small part. So I'm going to go back to the file merge pattern and just put that in there. 3D. Okay. Okay, so now I'll just go through the same steps again.
So now that we've run the preview of the second side of the mill job, we can write the G-code to put it into the thermowood machine.
Okay, so to do this, to write the G-code, select this toolpath group up top to make sure it takes all your folders. And then up here, post-selected operations, click that. And then this is your post processor, and depending on how you've set up MasterCAM, it should default to that. Click off OK. We're going to put this on the desktop. MasterCAM sets up its own folder, but it's really deep in there. And then over here, you have to do this shift for our machine, so we tell it to go to the side of the table that's closest to the computer, and that's how we set it up over here. And there's a reason for that, but
so it's 120.
Yeah. Oh, sorry. So 120 for the X, 60 for the Y, 0 for the Z. And then here's our preview. So the information over here, this is telling us the tools we need. So that's really helpful when we're downstairs in case we forgot, like if we set this up a few days ago and then we go down. So we've got 239 and 252, and then this is the shift that we just did. So X was 120, Y was 60, Z was 0, and spindle speed for the first part of the code is only 9,000, which is fine. That's what we had set up. And one of the, I guess like a troubleshooting issue, sometimes if you're downstairs running the mill and you see, if you get an error that says like X-axis out of bounds, for example, it's usually because your shift is a negative value, or just a huge value because you typed like 12,000 instead of 120, for example. So that's kind of the first place I would go to check if you had a out of bounds error. So you just close that out. Or I guess so this is the actual G code, is all these X, Y, Z values telling it where to go, and like over here, so you have XY, and then IJ, this is telling you that it's doing a curve somewhere. So down here at this line, it's going to start to turn. Same here, that's what the IJ is.
So once you have the G code, save
Yeah.
it to a USB drive.
Yeah, so that's, yeah, the G code is what we're actually going to, yeah, put on the USB, and then downstairs at the computer, as we were showing yesterday, you're going to open up that file, the NC file, the numerical code file.